Supersonic flight means traveling faster than the speed of sound, about 761 miles per hour at sea level. This speed is known as Mach 1, a term used to describe the ratio of the speed of an object to the speed of sound. When a plane flies faster than sound, it's called supersonic. This phenomenon creates a sonic boom, a loud noise similar to an explosion, caused by the shock waves created by the aircraft. This is a huge leap in engineering. Designing a supersonic aircraft requires advanced materials and innovative aerodynamics to withstand the intense forces involved. At subsonic speeds, air and sound waves move ahead of the plane, warning the air it's coming. This allows for smoother airflow around the aircraft. Commercial planes today are fast, but not supersonic. They don't outrun their own sound. They typically cruise at speeds just below the speed of sound, around 600 miles per hour. To break the sound barrier, a plane needs powerful engines and a special design. These engines must generate enough thrust to overcome the drag that increases dramatically near the speed of sound. As it nears the speed of sound, air can't move out of the way fast enough and pressure builds up. This creates a barrier of compressed air that the plane must push through. When the plane finally breaks through, it's officially supersonic. The transition is marked by the formation of a vapor cone and the release of a sonic boom. The first to do this was Chuck Yeager in 1947, flying the Bell X-1. This historic flight paved the way for future advancements in high-speed aviation. Supersonic flight could cut travel times in half. Imagine breakfast in New York and lunch in Los Angeles. This would revolutionize air travel, making long-distance trips much more convenient. It has the potential to make our world feel smaller and more connected. Faster travel times would bring people and cultures closer together, fostering greater global interaction. All thanks to the science of going faster than sound. The pursuit of supersonic flight continues to push the boundaries of technology and human ingenuity. Breaking the sound barrier creates a sonic boom, a loud, thunder-like noise. This happens when sound waves pile up and burst out behind the plane in a cone shape. The boom can shake buildings and shatter windows, making it a major problem for people on the ground. Because of this, supersonic flight over land was banned in 1973. Jets like Concorde could only go supersonic over oceans. This limited the usefulness of supersonic travel. NASA's challenge: can we have supersonic speed without the disruptive boom? The goal is to turn that boom into a quiet thump, unlocking faster flights everywhere. NASA's answer to the challenge of quiet supersonic flight is the X-59 QueSST, an experimental jet designed to break the sound barrier without producing the thunderous sonic boom that has long limited supersonic travel over land. Created by the legendary Lockheed Martin Skunk Works, the X-59 isn't built for passengers or commercial flights. Instead, it's a flying laboratory, packed with sensors and technology to test new ideas in real-world conditions. Its mission is ambitious: fly faster than the speed of sound but generate a sonic thump no louder than a car door closing, instead of the window-rattling booms of past supersonic jets. NASA plans to fly the X-59 over select U.S. communities, gathering feedback from residents to find out if the quieter sound is truly less disruptive and more acceptable to people on the ground. The X-59 joins a proud tradition of X-planes, experimental aircraft that have pushed the boundaries of what's possible in aviation, from breaking the sound barrier to testing radical new designs. If the X-59 succeeds, NASA will share its findings with aviation regulators, providing crucial data that could help rewrite the rules and open the door to commercial supersonic flights over land for the first time in decades. Years of painstaking research, advanced computer modeling, and countless hours of wind tunnel testing have shaped the X-59's unique, slender design, every detail engineered to minimize noise. Now the X-59 is ready to put all that work to the test in the real world, as pilots and engineers prepare for a series of groundbreaking flights. If successful, this project could bring us closer to a future where quiet, fast air travel is possible for everyone, making cross-country and even intercontinental trips faster and more convenient. Imagine a world where supersonic speed is available to all, without the disruptive noise that once made it impossible over land. That's the bold future NASA is working toward, one where innovation and technology make the impossible possible. The X-59's secret is its shape, especially its long, thin nose, about a third of the plane's length. This nose slices the air gently, creating smaller, weaker shock waves instead of one big boom. The wings, engine, and tail are all shaped to keep these shock waves from merging. The result, a soft thump instead of a loud boom on the ground. The cockpit has no front window. Instead, the pilot uses cameras and a high-def screen to see ahead. The engine sits on top, shielding the ground from noise and helping control shock waves. Every curve is designed for one goal, fast, quiet flight. The X-59 is built to fly at Mach 1.4, about 925 miles per hour, much faster than regular airliners. It cruises at 55,000 feet, higher than most planes, so its sound dissipates before reaching the ground. The target, a sonic thump of just 75 perceived level decibels, like a car door closing from 20 feet away. That's a huge improvement over the Concorde's startling booms. The X-59 uses a single, powerful jet engine adapted from fighter jets. But it's the plane's shape, not just its power, that makes it quiet. The combination of speed, altitude, and design is what sets the X-59 apart. It's all about flying fast, without the noise. Before flying, the X-59 undergoes rigorous ground tests, checking every system for safety and performance. In July 2025, it began taxi tests, moving under its own power on the runway in Palmdale, California. These tests ensure the plane handles well before its first flight. The first flight will be cautious, just a short loop to check systems in the air. After that, pilots will gradually fly higher and faster, expanding the plane's capabilities. Only when the team is confident will they push the X-59 through the sound barrier. This careful, step-by-step process ensures safety and gathers crucial data. It's all preparation for the ultimate mission-quiet supersonic flight. Once the X-59 proves it can fly quietly, a new chapter in aviation will begin. This remarkable aircraft is designed to reduce the thunderous sonic boom to a gentle thump, making supersonic travel over land possible for the first time in decades. NASA will fly the X-59 over carefully selected U.S. communities, each chosen to represent a range of environments and populations. These flights will help scientists understand how the quiet supersonic technology performs in real-world settings. Residents will be asked to listen for the thump as the jet passes overhead and share their honest reactions. Did they notice the sound? And if so, did it disturb them, or was it barely noticeable? Meanwhile, sensitive microphones and advanced sound measurement equipment will record the noise levels, providing scientists with precise data on how the sound travels and how loud it actually is at ground level. Surveys will be distributed to collect valuable public feedback, capturing the community's experience and opinions about the new technology. All of this data, both scientific and public, will be compiled and presented to lawmakers and regulators. NASA's goal is to provide the evidence needed to update the decades-old rules that currently ban supersonic flight over land. If the project is successful, it could open the door to a new era of air travel, where quiet, fast passenger jets connect cities and countries at unprecedented speeds. The X-59 itself won't carry passengers, but it's paving the way for future commercial aircraft that will. The technology developed and tested on the X-59 will shape the next generation of airliners, influencing how they are designed, built, and operated for years to come. Imagine boarding a jet and flying across the country in half the time it takes today, all while enjoying a quiet, comfortable ride above the clouds. NASA's mission is to transform the loud, disruptive sonic boom into a soft, barely noticeable thump, making supersonic travel practical and acceptable for everyone. With these advances, NASA hopes to connect the world faster than ever before, bringing people and places closer together in ways we've only dreamed of.